Good morning and welcome everyone. My name is Jacqueline Biron and today's topic is on oil sampling procedures. Drew McCrae, who is our presenter today, is with Blue Life and is a Reliability Solutions and Training Manager. We'll be getting started right away. A few details. This presentation is about 30 to 40 minutes long, and any questions, please feel free to type them in the comment area, and we will definitely respond to them either during the course by email, or we will be answering questions at the end of the presentation. Any questions we do not get to by the end of the presentation, we will be responding back to you either by phone or by email. Again, I will just hand this over to Drew. Drew, welcome.
Good morning. Thank you, Jacqueline. As Jacqueline mentioned, my name is Drew McCrae. I've worked at Fluid Life here for about 2 years. My experience is mostly plant-based. I do have limited experience with some mobile equipment, and that mobile equipment, being primarily mobile cranes. So yeah, I will be going through some of the best ways to do oil sampling and sample fittings that we can help you guys with. So just a few things about us. First of all, we're not just an oil analysis lab. We have lots of different reliability solutions we can provide for your site and for your equipment. Things such as sampling hardware, having that hardware installed itself, lubrication program evaluation, which we here call a scorecard, an oil analysis audit, where basically we go around and look at all your equipment and tell you how to improve your oil sampling practices. Same idea when it comes to a grease equipment audit. We can provide lubrication procedures for you, and there's many other projects, and we'll go over those quickly at the end. Also, we are a certified facility for providing the MLA and MLT exam, and we also do a bit of a non-certified training. So today we're going to be mostly focusing on why oil sampling is necessary, where, when, and how often to sample, various sampling methods, importance of having your bottles clean and flushing the samples. When we say flushing, we mean flushing out those dead legs and flushing out even the tubing that you attach to the bottles from the piece of equipment. And we're going to go over a quick overview on sample registration. For those of you who are interested in like the QR code side of things, we'll talk more about that next week. I'm just going to touch on registration in this week's presentation. So we'll get right into it. Some of the key points of sampling, as in your sampling objectives. So you want to sample a live system immediately or right after a shutdown if possible. Now, I do understand there's safety procedures for companies that say you are not to sample on live equipment and follow all your company procedures. That's primary. Number one is that your company safety procedures are followed. Using brake clean to clean your sample port is a good practice beforehand. That way, a lot of times you'll see, especially in plant equipment or mobile equipment, even more so, I guess, is that those sample ports are going to get caked in mud, and you want that to be clean first before you even take a sample. So pre-labeling your bottles immediately or after filling to avoid mix-ups. So what I mean by that is, if you do have that web-based app, scan that bottle just before you're about to sample it and then fill your bottle. When you have the labels, make sure you bring the labels with you and fill your sample with your piece of equipment and put that label on it right there. This is just to avoid that mix-up. The reason being is a lot of times you're going to be having two pieces of sister equipment and you want to sample both. You want them labeled correctly just in case one is a bad actor, one is not, and you don't want to accidentally have that one sample that is mixed up, and then you don't have proper data going for your samples. So again, like I mentioned, flushing is really critical to having a good representative sample as well. Sampling when, where, and how often. Number of samples really depends on your program's goal. Are you trying to monitor your filter performance? Are you trying to diagnose failures, looking for where contaminations are coming in, or are you trying to determine oil change intervals? All this is really important. So if you're interested in bearing condition, pump condition, filter performance, the overall system performance, all these are things that are you're going to have to take into consideration. So this is just a basic overview of oil sampling procedures and where to do it. So we just developed a table that makes it really easy to understand, and we can get this provided out to you guys if you guys need it. Just we will be in contact, and if you would like a copy of these procedures, by all means. So basically, with engines, typically you're going to sample valve upstream of a filter. So basically, after a pump but before a filter, it's going to be your best place to sample for an overall idea of how your performance is, your equipment performance is. Safety-wise, when it comes to engine coolant, do not open a radiator cap until the engine is cooled off. This is just ensure safety precautions have been taken before opening a radiator cap. You don't want to be sprayed with hot fluid. I mean, that's not good for anyone here. Sample valves are typically installed, again, upstream of a coolant filter. Transmissions, drain plugs samples can only be collected when the oil is really being changed. So consider doing other methods for collecting your in-service oil samples. For example, for remotely located dipsticks, ensure proper dead space flushing procedures have been followed. So determine how long that dead leg is, and make sure that's all flushed out before you're taking your sample. Samples, again, are usually installed upstream of a transmission oil filter. You can kind of see the trend here. You want to sample after pump, before a filter. Hydraulic samples, drain samples can be collected when oil is being changed. Other ways of doing it is doing especially if you have a tank for hydraulic fluid, is have a breather adapter kit. And when I talk about all these sample valves, and as you can see on the chart, the tables as well, we're going to go through each of the different ones that you can use. So basically, with the hydraulic one, you're sticking a tube with a breather kit on it into the hydraulic tank, and it'll draw from the same spot every time. Differentials, drain samples can only be again collected when oil is drained, but there's other methods such as cover plate adapters, and same with the final drives. You can have that kind of thing as well. For fixed equipment, a lot of the same processes especially for like hydraulics. You're going to want to be sample from that same on the tank at the same spot. Circulating oil systems, you want to take a sample from where you're going to be, depending on what you're monitoring. So again, if you want to monitor filter performance, or if you want to monitor how bearings are performing, that all depends on where you're going to sample from. But generally, you're going to want to take it off the tank or after pump, before a filter. Samples taken from return lines, they are really good for showing damage in the system. Samples taken after a filter are really good for showing your filter performance. And samples taken immediately after components, such as like a pump or after a bearing, is really good for drilling down to how that component is performing. There's examples where I've seen in plant-based where we've had the client had a sample valve after every bearing on a piece of equipment, just to see how each of those individual bearings are performing. And they'd have one on the tank, they had one after every pump. It was very sophisticated to see how in depth people really do go, and really all depends on the criticality of your equipment. For example, you're not going to be sampling a pump that has half a liter of oil and you have 8 of those pumps that are performing the same function. I mean, by all means, sample it when you go to change the oil, and then take that sample. And it's really good for being able to determine when to put that PM in to go change that pump. So it's really all depends on the criticality of your equipment. So frequency, general guidelines for sampling are just a starting point. Frequency depends on a lot of several factors: the load, the environment, the temperature, the speed of your equipment, downtime cost, repair replacement cost, safety requirements, equipment tolerance, contamination factors, and criticality, as I mentioned. For example, diesel engine running a hospital generator with 4 installed spares is a lot less critical compared to a piece of equipment that has a known failure history or has been failing because sampling hasn't been done correctly. Now here's just a general guideline for sampling frequencies. You can see this is a chart that we can provide you guys with if you would like. But again, criticality needs to be considered. If the piece of equipment is tending to be failure, or there's more significant problems that can arise, you may want to increase that frequency. What I've seen done a lot is where a piece of equipment that's had known failure history sampled a lot, like we'll call it every 2 weeks, for example, and then they've repaired that piece of equipment, then you start tailing off your sampling frequencies, because you don't need to be sampling something every 2 weeks if every time you take a sample, there's no problems. So that's where you can start paring back on your sampling frequency. So methods. So a common method of sampling is midstream from a reservoir into a sample bottle. So I know a lot of cases, a lot of plants don't have the proper sampling fittings, and that's fine. I mean, if you guys are in an infant stage of your lubrication program, starting sampling is a good place to be starting. A lot of places will also do the drop tube. Now I've seen this where they'll open up the top of a gearbox where the fill cap is and stick the tube down, or they'll do that in a hydraulic tank, or even in engines. People will take it down the dipstick and they will fish the drop tube down into there. Now, drop tubes aren't the best. The reason being is that you're not always going to be going down this same distance, and 2 different technicians aren't going to be sampling the exact same way. Whereas if you had a proper sampling port, it's going to be consistent. So when it comes to sampling, consistency is your key. Another issue that arises, like I seen this when I was in a underground mine, and the conveyor belts where the gearboxes are, they would open it up, and it was a very, very dusty environment. They would open up the fill cap, and all this debris would fall into the gearbox when they go to take a sample. So right there in itself, your sample is contaminated, and you're introducing numerous contaminants into your gearbox. So just having proper sampling ports and drop tubing isn't ideal. Now, I'm sure some of you guys have seen this here. This is a very useful tool for low or non-pressurized systems like gearboxes, bearings, reservoirs, and return lines. We suggest using a new section of tube every time, flushing out that tubing before every sample. Now, when you use one of these, it's very easy to use. All you do is you stick the tube into here, and this nut will tighten onto the sample. You depress the plunger a few times, and it'll automatically start filling your sample bottle as it's created a vacuum. Once you crack the bottle from the seal, it'll stop filling. The key is to only fill it about 80%, about up to this rib here on the bottle. Reason being is you get oil or hydraulic fluid into the suction pump, it can damage the seals, and you're needing to replace seals or the pump altogether. So here are some really good tools, and we can provide all this stuff for you guys. This is used for low pressure. These work with suction pumps. The M series valve, which is we call it M series valve, which is this one here, and this is the low pressure one. Same with this one here. This one just has a pitot tube on the end, and this one here, same an M series valve that has a pitot tube. Now these are really good for using on a gearbox. Example for this, the level gauge one, you could use this and just curve this tube up just a little bit so it's out of that bottom sludge line in your reservoir or in your gearbox. This one here is called a breather adapter kit, and I kind of mentioned it earlier where or a hydraulic kit as well, where you would drop this onto the fill cap and this would pull it up from the exact same spot every time. What's really nice about this is, and we'll cover this in contamination control in a couple of weeks in that webinar, it will act as a desiccant breather. It'll let you know if there's any vacuum that's occurred. It's a fill port, as well as a sampling port. And that you can see here the tube here. And again, taking it from the exact same spot every time, just above that sludge line. And what's nice is you can even have those tags to identify your sampling point or your piece of equipment right on the sampling port there. What I've also seen with these ones too on a gearbox is you could have these drilled and tapped right into the gearbox. Some of the more new gearboxes I've seen on plant sites out is they already have these already in the side of the gearbox just above the fill port. So it's already all there for the technicians to be using. Now on pressurized systems, same idea. This fitting here, this basically screws onto the valve here, and there's a little valve a needle in here that presses a valve in this piece of in this part of the sampling valve, and it draws the sample out. Now you would use something very similar to this for the M series valve right here. The push button is an even easier method. I was recently at a pulp mill and they started implementing these all over the place, and they're excellent. There's no need for extra tools. All you do is unscrew this cap and you fill your bottle. Excellent, easy method for the technicians. My thoughts are, make it easier for people, it's going to happen, and your program's going to be a lot more successful the easier you make it. And again, I kind of mentioned this before, safety is critical. Like whatever your company policies are, please follow those. It's critical to clean your valves and follow all safety procedures. Oil can be really hot and it can be dangerous, especially if there's high pressures involved. Other different sampling valves that are very common. This is called a KST valve here. And basically what it is, we've all seen those basketball needles that you can use for filling with air. Basically it presses another little valve in here and fills the sample cup. Caterpillar has a very similar one like this that you can use. And as well as there's a cover plate. I kind of mentioned this earlier about sampling differentials and final drives and such. You can see here on this differential here how there's a cover plate and a suction pump. So basically what happens is on the other side, there is a valve, there is a tube as well that'll pull it up from the same spot every time. So as you can see on the first slide that we had there was just the open sampling port where the tube was pushed in. This kind of works in the same way, but you're sampling from the exact same spot every time. The nice ones about these two is that you don't have to screw on the fitting like you did with the B series valve like you saw on the last page. Some of the more uncommon types are the inline T adapter, which is basically this goes in between two fittings, and you have a push button, or you can have a B series valve on there as well. The ones I'm not so much more familiar with are the flush mount drain on a non-pressurized system, as well as the dry plug. More of the other uncommon types is it's a little difficult to see here, but you can see there's a spacer flange, and basically you could put a valve on there, a push button or a B series on there. A catch valve, I myself have never seen these before, but I get how they work. The oil will flow through here and will catch, and you could get a good oil sample from there. On this one here, a valve mount, essentially what it does is it's really good for smaller tubing, and the tubing goes through here, and this valve block is clamped around it, and the valve will be screwed down and it will pierce into the valve, for your sample. A bacon bomb, this is really good for those really large underground tanks, or a rail car or a truck And basically what will happen is the density of the fluid will depress this little valve and fill the sample port. So lots of really interesting ways to sample. There's many ways to sample, and these are things that we can all provide you guidance with. So sampling how? More of the bottles and the flushing. So interestingly enough, everything you see on the slide here, we've had samples come in with that. We've had bags, we've even had film canisters. I don't even know if you can find film canisters anymore, but that's what they've come in. Cleanliness, it's super critical. So new sample bottle cleanliness will have an effect on your oil analysis results. So if you take your bottle and you leave it open, you're not going to you're going to collect anything that's in the facility into your bottle or in the atmosphere that you're sampling. I kind of mentioned before, when you're filling your bottle, you want to fill it up to about here. This allows it for the bottle to be shaken a bit when it gets on site, so we can resuspend any particulate or water that would happen to get into the bottle. Storing samplings for oil or for lab analysis. The sites that I've worked on in the past, we would always sample a Monday morning, and then we'd have the samples out Monday afternoon to the lab. The reason being is if you're sampling later in the week, we all get busy, we forget about samples, and they sit on the desk. I've seen it numerous times. I've gone around and done the oil analysis audit, and I've asked guys, hey, what about these samples here? They say, oh, don't worry about those. We've sampled 3 or 4 times from when we sampled those. So they're month-old samples that could have given you a precursor to or an issue happening with your piece of equipment. So really important to send those samples out as soon as you get them. Flushing, 1 sample, 1 tube. Never reuse a sample tube, even for the same location. You got to flush it at least 5 to 10 times the dead space volume. New tubing volume, dead legs, sample ports, adapters for vacuum tubing, pump, plastic tubing. There are tables and charts and calculators that are available to help you determine how much of that dead space there is. Ideally, you want to sample as close to the piece of equipment as possible. Being is you don't want to be draining all that oil. That's all you're draining a bunch of oil that needs to be in the machine. So either you're dropping the oil level just for a sample, then having to go fill oil up again. So it's just really important to make sure you're flushing that correct amount and not being too far away from where you have to be sampling when you actually take your sample. So registration, like I mentioned, we're just going to touch on this one here. An incorrectly registered sample is just as bad as a poorly drawn sample. Reason being is you have incorrect oil, incorrect service, incorrect unit or component. I've seen in lots of situations where in myself, for example, where I've sampled my own oil for my vehicle, where I put in 10W40 by accident and my vehicle runs OW40. So of course, when I get the oil results back, it's way out to lunch. Putting in the incorrect service. So if you say put in 20 hours instead of a piece of equipment that's run 200 hours, there's going to be a big difference on that. You see, if you're starting to see 20 hours, there's a big issue. When after 200 hours, that's normally you see that's going to start raising alarms. So there's a few different ways we do sample registration. It can be done via the mobile app, the web-based app, which in my lab, and the traditional sample card. So if you guys are interested in that, please do sign up for our next webinar, which is going to be sampling registration, and we'll give a really good detailed explanation of that. So basically, as a summary of today, basically now is the time to start your oil analysis program. Oil sampling program, I'm sorry, if you haven't started one. Number of samples and sample points really depends on your program's goal. Follow standardized frequencies to start. Continuous improve process and procedures to find what really works for you. So again, when we showed you those charts, those are just general standards. Every site's going to have their own nuances and be slightly different, but whatever works for you is good. Starting an oil analysis program is better than not having one in the first place. Samples, they should be shipped to us as soon as possible. Delayed samples should be stored in a dark climate controlled place, but again, get them to us. And I missed one here, sorry. Ensure sample cleanliness by using the proper sample bottles and proper sampling procedures that are best suited for your pieces of equipment. We can review your current oil sampling program and provide recommendations for improvement. For an example on this one here, I worked on a plant site where they would never using proper sampling ports. They would just use like those gate valves like you would use for a garden hose. And what happened is one of our technicians had accidentally left one open just on a small drip, and again, small things happen. And what happened is that it was about 100-foot by 30-foot oil room, and the room had about 2 inches of oil in it. And the operator had noticed that the compressor kept setting false alarms, and we had another technician walk by and seen oil pouring out of the room. So that's kind of things where we can help improve you guys. Ensure proper sample registration. Again, an incorrect registered sample, just as bad as a poorly drawn sample. So I'm going to give you guys just a quick overview where you can find our reliability products on our website. Super easy to find them. All of our laboratory services, the customer care desk, which can help you order your sample bottles, order your sampling ports, reliability solutions, which is the products and the services we can buy, and also the training solutions. So as you can see here, sample kits, very easy. Just click on here and you'll be able to go right to our order desk and they'll be able to help you out. Same with our sampling hardware. We got a very valuable resources for this. We have a gentleman here who's very knowledgeable with all of our fittings and pumps and accessories. Very good for helping that. I know there was a quick question about QR tags, and these are what you would attach to your piece of equipment, and you'd scan that, and then you scan the bottle and your sample's registered. And again, order desk, you need to order them right there. Our sampling procedures, now these are all PDFs that are general ways of sampling. If you guys need more in-depth sampling procedures or SOPs created, that's a service we're definitely able to provide you guys with. And easy on the website here, our different ways that I had mentioned for registering your samples via the mobile app, the web registration, the sample card. And furthermore, this is where our reliability solutions and projects come in. So we got a scorecard kind of giving you the overall value of your oil analysis program, doing an audit and seeing how well you're sampling and the procedures that are being followed, and recommending different sample ports you could put on your piece of equipment, frequencies, oils. Similar idea with greasing equipment. That's one that a lot of companies are kind of miss the mark on, I guess is the best way to put it, is a lot of undergreasing or overgreasing or even incorrect greasing being used. More of our checkpoint management basically is where we'll take and put all of your tasks into fluid life, flagging optimization, optimizing how all your flagging limits, process mapping. We'll do lubrication policies for you as well. And for the more mature programs, we can perform preventive maintenance optimization, criticality analysis, failure mode and effects analysis, even a failure analysis. And what I mean by failure analysis is like like a metallurgical failure analysis. We're able to provide that as well. Root cause analysis, and we do have vibration services as well. Training, I mentioned that we do various trainings, and you guys are in one right now with our online webinar sessions, and I'm thankful you guys are all able to find that. We also have a private training webinar based and private training in class when all this craziness in the world gets figured out. And we have the MyLab tutorial. So those of you who are using MyLab, if you have some questions on how to use it, that's all available as well. And just we do have the ability to help with the Canada Job Grant. So basically, if you have a group of people who want training, that's certification training, the government of Canada is able to help provide some financial cost coverage for that. So I'm going to turn it back over to Jacqueline here, and if you guys have any questions, please feel free. Thank you.
Thank you, Drew. So I'm just looking through here. I do have one question here, and I'll let you respond to it. What's the maximum pressure you can safely sample at?
Sorry, say that again, Jacqueline.
What is the maximum pressure you can safely sample at?
Really depends. A lot of these valves will have about 125 psi sampling pressure, but I myself wouldn't suggest sampling any more greater than static pressure. It can be dangerous to sample, so it's really good to have check valves right near where you're going to be sampling.
Okay, thank you. I do not have any other questions listed here right now. If anyone does have a question after this, feel free to email either myself or Drew, and we can definitely help you out there. There's a few things that did pop in that we will respond to here. Otherwise, if there's nothing else, we will say goodbye, and thank you everyone for joining us.
Thank you very much, everyone.